Well, all right, folks, we're here to investigate a function. We've arrived on the crime scene. Sorry, that was a really lame joke. We're investigating this function, and we're not going to do it the way that you may have done it before. I'm going to be talking about some new vocabulary. So intervals where things are increasing and decreasing, and concavity, whether it's concave up or concave down. So, investigating a function. So suppose you had a picture of this graph and your partner couldn't see the graph and you had to describe that graph to them. Could you do that? Well, certainly you could say, all right, well, it's going to cross the x-axis here. You know, you could figure out what those points are and you could say, okay, that's where it's going to cross. What else could you talk about? You could talk about where it crosses the y-axis. And then from there, you'd probably want to say, well, it's a curve. It kind of goes up for a bit and then it comes down and it goes up again. But that wouldn't be very specific. So what you would want to do is you'd want to describe, well, the graph is increasing. In other words, it's from left to, as we move left to right, from smaller x values to bigger x values, the graph increases. It looks like it increases right here. It's going up, right? And it's going up here. So how could we communicate that reasoning? Maybe you could pass your neighbor a note and it could say, it's increasing. And I'm going to go back to the interval notation that we use in domain and range. So the interval notation would say from where to where is it increasing? So we're going to refer to x values, okay? So the x values, this is negative infinity down this way, at positive infinity is this way. So from negative infinity, oh, it's increasing all the way up to where? Well, it looks like right about here. That looks like approximately negative 1, 2, 3, negative 4, right? Because all the way up, it increases all the way up to negative 4, right? And then it also increases over here. So that like from here to here, it's decreasing. So we're gonna unite that with another increasing interval from, what's this? 1, 2, 3, looks like about 3 to forever, right? It goes, that's arrow means goes forever, so it goes up forever, right? And just a small note, you might be thinking, should I put a bracket here? With these intervals right here, we're not going to be using brackets for that, because it's not increasing at negative 4. That's where it stops increasing, right? All the way up until negative 4. At negative 4, it's not increasing or decreasing. It's actually constant right there. It's not in a process of increasing or decreasing. It's a local maximum right here, and it's actually a local minimum. So in this region, this is the maximum point, and this is the minimum point down here. That'll be another concept you'll come back to. So let's continue on. We need to tell our partner when it's decreasing. So when is it decreasing? Well, it looks like it's increasing here and increasing. So in the middle, it's decreasing. So it would be decreasing from, well, right in between, right? So negative 4 to 3 is where it's decreasing. The graph is certainly decreasing. Okay, so you could tell your neighbor the graph's increasing from left to right, from negative infinity to negative 4, and then from 3. So they would understand that it's going this way and this way. They still might be drawing a graph that looks like this. According to what you told them, they could draw this graph and it would logically make sense with what you told them. But clearly this graph is not this graph. So what's missing? Well, you could say, oh, it curves. Well, you could say it's this. That one curves, right? Maybe that decreases a little bit there, but my goal was to show that it can curve in a lot of different ways. And so we're going to use these words to describe how these curves look, and it's called concavity. So there's this thing called concave up. All right, concave up, and concave up means it's got this parabola shape where it's opened up. So the endpoints are opened up, right? It's this shape. Concave down, as one might guess, is the exact opposite, right? It's like this. Now, I drew parabolas here, or my best estimation of what a parabola looks like, or not the best at drawing, but the problem is we have concave up, but it looks like, I mean, certainly this isn't this, the whole graph, because it kind of does both concave up and concave down. So sometimes we have just portions of a concave up and concave down. So what you need to look at is what's happening kind of right in the where the vertex is, right? So right in this area here, what's happening there, like where it's turning. So focus on where it's turning and figure out, is it going to match this concave up piece or this concave down piece? So where does it turn? All right, well, the first turn is here. So it must be that this portion right here is concave up, or I'm sorry, down, because it's looking like this, right? So this is concave down. And then at some point between this vertex and this vertex, I should say this local maximum and this local minimum, it switches from being concave down, right, to concave up. So somewhere around here, somewhere in the middle, it switches. So if we were to explain to our partner, again, what it's concave up, so we would give another interval. So concave up, and we would say something like negative infinity all the way to, and it would be really the midway point between these two is when it would switch. It would go from being this way to curving the other way. So it'd be right in the middle. And I'm gonna go ahead and estimate that. When you have other graphs, you'll be able to see. So -1 all the way to about -1. And then for concave down, it'd be concave down from, oh, you know what? I just did that backwards. Why did I keep switching that up? Oops. Hopefully you're watching this video like, no, Mr. Jameson, it's not that. Negative infinity to -1. It was concave down. That was that one. Concave up would be, so from -1 to infinity, right? So that'd be the other interval where it's concave up. I don't know why I mixed those up. So these instructions would be able to tell your partner enough to get a pretty approximate graph. I mean, I think that you would want to tell them where it crosses the x-axis and y-axis, but that's how you would communicate that reasoning. And so what we'll be asking you to do is investigate functions, tell us when it's increasing and decreasing, tell us the concave up and concave down intervals, and then we would also talk about local maximums and local minimums. And that's just in the smaller region. Certainly the absolute maximum value in this would be infinity because it goes up forever eventually. But in this region here, the maximum is right there. And in this region here, the minimum is right there. So it's got a local maximum and minimum. And those would be the things that you would add to it. Hope that helps. Good luck.